All right, welcome everybody. We're going to be talking about classes today. So the syntax for a class or a struct, let's go ahead and start from scratch, looks something like this. Struct, I don't know, food item, food item. And every food item will have a name, a string name, and it'll have a calorie count. And I don't know, what else? What else describes a food, an item of food? What do you think? Color, maybe. Weight. What do you think? Weight. Yeah, let's do weight. Let's not go too overboard on this because it'll just end up being a lot more typing. Price. Yeah, that's a good one. Price should be maybe a float. Maybe. Right. Okay. Weight. What do you think? Weight maybe should be a float also. Calories. Calories can be an int. We usually talk about calories and full numbers. Okay. So this is how we learned how to do classes in CSci 40. And for those of you that didn't have me for CSci 40, maybe this is new for you. So I'll go over it really fast. This creates a new type, like int or float or double or string. We now have a type called food item that we can make variables of. So I can make a new item called food item, and this is going to be called banana. Banana equals banana. Banana is 100 calories. Weight is how much banana weighs? 0.1 maybe. Price is $1.50. Something like that. And so when you initialize a struct like this, the first thing you put within curly boys here is the first member variable. Second one is the second one, third one's the third one, so on and so forth. So if I were to see out banana dot weight, that's how you grab member variables out of a struct. Just say dot and then the name of the member variable. What is this going to print to the screen? What do you guys think? What is that going to print to the screen? You guys are mostly correct. Yes. Very good. Yeah, 0.1. All right. So if we run this, 0.1. Cool. So that's pretty easy. And so this is something called a pod, or sometimes called pods, which stands for plain old data. And there's actually a function in C++ called isPod. isPod food item. And that'll actually tell you if food item is a pod or not. Something like that. I don't know. I never use it. But yeah, you can actually, this is actually part of the official language. And what isPod means is that it's just a bunch of variables like living together. Okay. It's just, sometimes if you need a function that returns multiple things, you can have it return 4 things at once, like get food, get food, and like return banana. Right. And so functions can only return one value, right? And so if you want to return 4 values, then, well, this is a pretty easy way of doing it. Just make a struct that has 4 things in it and then return it. You guys understand? Is that pretty, not too bad? Pretty easy to understand, maybe? Makes sense? So we're returning a banana here, and then this guy is catching the return value from the function, and we've got access to all 4 of these things here. Cool. Okay, so what we're going to learn today is the alternative way of doing classes and structs. A class and a struct are exactly the same, except a class defaults to what is called private. And so if you do a class and start off with a line public, that's exactly the same as using a struct. So a struct and a class are exactly the same, except structs default to public, classes default to private. So what does private mean? Private means, public means anyone can access and change the whatever. Okay. Private means only things within the class can access and change it. Okay. So if you make it private, which it is now, because this is a class and it defaults to private, classes default to private, structs to public for everything, even in inheritance, which we'll learn later. You can't do this anymore. You can't get dot weight. You can't set name and calorie and weight anymore because this is now protected. It's the only things that can read and write to name and calorie and weight and price are things within the class. Is there anything within the class right now that allows you to read and write to it? Or is this class just completely pointless right now? What do you guys think? Is there any use to this? I mean, I'm sure there's some pendant on the internet that is like, well, I could use it even though you can't read or write to it at all. Has a certain amount of RAM, whatever. No, there's no use to this. This is pointless, right? You can't do anything with it, right? If you can't access it as limited functionality to the end use, yeah, there's just there's no real use case for this. Pedantry aside. So what we have to do if we're going to be doing a class is we are going to be doing today something called an ADT, which is also called double quote proper class design. So we're learning ADT stands for abstract data type. And the reason why it's called that is because let's say that you were making let's say that you are Mr. Library, right? Did you guys all know that the standard library is named after Mr. Library? The author of the... No. Not... They're not buying. Okay. Let's say you're Mr. Library and you're working on the standard library. And you've got some cool sort function, right? You guys remember how to sort a vector? Right, you got a vector events named vec. It's equal to 20, 10, 100, 30. You guys remember how to sort it? You know the name of the function to sort a vector? Anyone want to guess? What's the function to sort a vector? Sort. Very good. Okay. So we'll sort vector.begin to vector.end. And then after we're done with that, we'll go ahead and print out the whole vector. For every integer in the vector, see out that integer. Okay. You can see it sorts least to greatest. Now, which sorting algorithm is sort using? Is using quicksort, heap sort, merge sort, selection sort, bubble sort? Which one is it using? Anyone know? Anyone care? I kind of care. Not really. And the reason why I don't really care is because if you look at the documentation, CPU reference for sort, the sort function has a interface. It takes in the beginning of the range to sort, the end of the range to sort, and then you can pass in a comparison function if you wanted to sort greatest to smallest instead of smallest to greatest, things like that. Okay. And we have a guarantee of how long it takes. It takes order n log n time, which means if you have 8 million elements in your vector, it'll take roughly 20 million operations to do. So that means by looking at this, it won't be bubble sort, it won't be selection sort, because both of those are order n squared, which means if you're trying to sort a vector of size 1 million, it'll be doing 1 million times 1 million, 1 trillion operations instead of 20 million. Those are too bad. But beyond that, I don't care. You guys understand? Like there's an interface. The interface is it takes in the beginning of the range and the end of the range, and then some other optional parameters. Basically, it takes in the beginning and the end, and then it sorts it. Do I care if this sort was done using quick sort or heap sort or merge sort or one of these other in-log-in algorithms. What do you guys think? Any of you guys care? Or do you just are like, hey, it works, you know? Doesn't matter for functionality. Yeah. Like, if tomorrow I updated, you know, I did a sudo apt update upgrade. If tomorrow they switched out the algorithm so that instead of using quicksort, it uses heap sort, do you think I would notice? Do you think I might? Like, I'm like, oh, it's running faster now, or you know, like, you know, oh, that's weird. It's running 10% faster now. That's strange. You know, but like basically from a correctness standpoint, I wouldn't know. Right? It's still, there's an interface. Do you guys understand? The interface is the name of the function is sort, and it takes a beginning and an end, and maybe some optional parameters. And it sorts it, least to greatest. And as long as they keep their promise of like, that's what the parameters mean, they don't switch, you know, the beginning and the end, right? All of a sudden on me. As long as they stick to that well-established interface, I don't care how they implement sort. I mean, I kind of do. Like, you know, it's like, you know, I'm a curious person. Like, oh, you know, let's look at the source code maybe sometime and see which one they're doing, or maybe it's a hybrid approach. You know, like, you know, out of curiosity, I might care, but like at the end of the day, it sorts my vector, and I don't care, you know, from a correctness standpoint beyond that. And so this is why, when we're coming to proper class design up here, if you are making a vector class or if you're making a hash table or something like that, at the end of the day, the people using your hash table or using your vector or using whatever don't really care how you do it, right? You have an interface. You say, this is how you put things into the hash table. This is how you put things into the vector. This is how you take things out of it. And as long as you stick to that interface that's published and well understood, you can change whatever you want behind the scenes. You know, you can make it faster, right? Do you guys understand what I'm getting at here? Whereas with this, if we have plain old data, if I decide that instead of a string, I want to use like, I don't know, a char star or something like that, which is a C style string, then all of a sudden everything breaks. Right? Now everybody using my code now has their code broken. Yep, that's not good. So I'm stuck, right? So if I've been using a char star all along and I want to switch it out for a string, and all of these people were doing things like, you know, newing RAM and passing in pointers and stuff like that, all their code breaks. And they probably have code in there to delete the strings, and all of it breaks. And that's why plain old data is considered poor design. And again, I'm putting air quotes around all these things because people have opinions in computer science. They have very strong opinions on both sides. They're just like, this is the right way of doing things. And I'm fairly agnostic when it comes to those things. Like, I can code, you know, any which way. But if you're going to be doing something like in a large system with lots of people using it, you don't want just everything to be plain old data, because you're stuck. You can't change anything anymore. If you change anything, if you change the name of, you know, if you change the name of calorie to calories or something like that, everything breaks, right? Like anybody who is like C outing banana.calorie, it breaks. You understand? And so you're stuck. You can't fix things. In order to fix something, you have to find every place in your millions of lines of code where somebody uses a food item and update it. And that's really terrible, because when you have a really large code base, everything ties into everything else, and it just gets really bad and unmaintainable after a while. So let me show you the proper way of making a food item. Okay. Then I'm going to give you guys a half-built class, and you're going to finish converting it from an ADT from a pod to an ADT. So convert from a pod to an ADT. Step 1, make all member variables private. And this is especially important if you have a class invariant. So what is a class invariant? If you have a class invariant, you must do this. There are times when I would say, it's fine to have a public member variable. But if you have a class invariant, you have to make them private. A class invariant is something that must be true about that member. So for example, can you have negative calories on a food? I wish. Ice, I think, technically has negative calories. It requires heat to melt the ice. Yeah. But yeah, pretty much for any food item they're going to be selling, yeah, you can't have negative calories. What if you did this whole thing here and like chewing gum? Yeah, kind of doesn't make sense. What about negative weight? You have negative weight. No. Negative price, maybe. Unlikely, but technically, here, I will pay you to take my chewing gum. Maybe, I don't know. Coupons, yeah, it's maybe, it's extreme couponing. Yeah. So you have to think about what rules have to be enforced for your class, because if all of your stuff assumes that the rules are being followed and they're not, then you can end up in a bad situation. Have you guys ever heard of this indie game called Pokemon? Anyone? Think so? Vaguely. Never heard of it. It's like a Japanese import. I don't know. Yeah. I'll try and find a better example. But anyway, in this indie game Pokemon, when you attack somebody, the amount of damage you do is a ratio of the attacker's attack to the defender's defense. So if the attacker attacks with a power of 10 and the defender defends with a defense of 5, then you do double damage. Okay. What happens though if you have a defense of 0? It's Jover. Right? It's kind of like it's kind of like Digimon. Yeah, if you're familiar with Digimon, it's kind of like that. So or Pocket Monsters. Yeah, it's kind of like that. Ni no Kuni. If you ever played Ni no Kuni. So if you the Cowboys defense. So if you have a defense of 0, your code will crash. Right? You're in bad trouble. So you really need to enforce a rule that I think they're joking, Cardenas. You really need to enforce a rule that defense can't be 0. Do you guys understand? Like if you, because somebody at some point will try to set it to 0, right? Like just by default when we make a variable, we'll just say, we'll just set it to 0, right? So it's really important. Are you guys with me here? So like if you have a Pokemon, the Pokemon never have a 0 defense because that will just explode your code. You guys understand? That's class invariant. So like a class invariant would be defense can't be 0. Probably negative defense doesn't make sense either. So and so when you make a class, you want to write these things down, right? And so like what things would make sense for name? Like what rule should we have? Let's write down our class invariants here. Class invariants for food. Like we're making a grocery store app. Like maybe we're doing one of these like self-checkout things, How many people here like self-checkout? Not me. Worst. I like self-checkout when I'm buying like a single thing, like I got like a gallon of milk or something, and the lines are like backed up, and I'm like, all right, I'm going over there. Beep, done. But man, like the last time I used it, the bags were all screwed up, and I'm sitting there like trying to like get the bags all fixed, and the machine's like error detected in the bagging area. I'm like, I know, like the bags are screwed up, dude. Like, and like flashes the light, and a person has to come by and clear it. You're just like, I'm just trying to buy some milk. Yeah, yeah. So, what class invariants? What must be true about the name? What do you think? Yeah, pauses for 10 seconds. Like, and so I always drop it on the tray. Like, okay, it's in here. I thunk the, like, I get some like gum, and I'm like, bunk, you know. Oh, it's okay. What must be true about the name? Let's come up with some invariants. Class invariants for food. What's a good rule for name? Name cannot be empty. I think that's a good one. Yeah. Good, Luke. What else? Can't start with a number? Okay. So if you're buying 30 below products, I don't know. I don't know about that one. Maybe must be. Do we have emoji in the name? Is that allowed? Emoji. No special characters. Cannot be empty. No special characters. What else? There's one invariant that I wish Stellaris dashes. Yeah, maybe dash is okay. Stellaris has no maximum string limit on usernames and system names and things like that. And so one of my friends, whenever we play Stellaris together, he copies the entire B-movie script, and then on his username hits paste. And then every time he says something within the game, the screen gets completely, exploded with the entire B-movie script every single time. Hi, and you go into a system, and it's, the name of the system is just it's all text, like you can't see anything. Some people say that bees can't fly. How does it go? Public. And yes, I do have it on the server. According to all known laws of aviation, there's no way a bee should be able to fly. Its wings are too small to get its fat little body off the ground. It's not actually true, but it's a fun way to start a movie. Okay. Like jazz, Kearney? I tried getting into jazz. One word. I would say maximum length of, I don't know, 30, 50, 80. What do you guys think? Oh, that one. Yeah. What do you think the maximum product length of a item should be in our self checkout system? Or like we die, like we reject the item if its name's too long. I used to have this problem with street names. I used to live on a street that has a really long name, and so like I literally couldn't. Like I take the SAT, you have to like bubble in your address, and it's like chopped off, and I'm like, oh no, I'm not going to get my results, am I? 255 characters. All right, maximum length of 255 characters. All right, what about for calories? What rules should there be for calories? No negative calories? What do you think? Is 0 calories okay? Are there any products we would sell at self-checkout that have 0 calories? Yeah. Okay. Water. Sure. So calories must be greater than or equal to 0. Splenda. Sure. A lot of 0 calorie foods out there. Okay, so we have a rule. And so if anybody ever tries setting calories to a negative number, we shouldn't allow it. Like a class invariant is rigidly enforced. Like you should have no way that somebody could come in there and give your product a negative mass or something like that, right? Maybe a balloon. Maybe a balloon. No. Let's do mass instead of weight. What if we're in outer space? Then there's no weight. Balloons are. I mean, at Save Mart they sell inflatable. You know, technically, I don't know. Let's pretend that doesn't exist. Or we'll just look at mass, because mass can't be negative, right? Unless you have exotic matter. So mass should also be greater than or equal to 0. Coding for grocery store in Starfield, right? Yeah. You go to a different planet and all of a sudden the weight changes. You know, it can be annoying. Mass is better. Mass Effect. Mylar balloons, yeah. What about price? Are there any rules for price? Our helium supply is running out, kind of. Yeah, kind of. Nuclear reactors make more helium, but there's enough naturally occurring helium. We're fine for a while. We did dump our strategic helium reserve, which is, in my opinion, a stupid idea. What about price? Any rules for price? Is the price pre-tax or post-tax? I would say pre-tax, maybe, but I don't know how we would put an invariant for that in it. Normal integer limits should be fine. So greater than 0. Yeah, probably. So price should be greater than or equal to 0, and maybe what's the maximum? Because floating point numbers can get really big, and I would assume that at a grocery store it would be an error if you tried buying a chocolate bar for $1 trillion. You know, like what do you think the biggest single item you could buy at a grocery store is? What's the lore of our store? I don't know. I guess I'm kind of imagining like Vaughn's or something like that. Costco alcohol. Yeah, like what's the single most expensive thing that somebody could reasonably buy at like a Costco? Like a house? I don't know what they sell there. Gold bar, 30,000, 100,000. I don't know. What do you think? 100,000 solar panels. Can you buy solar panels at Costco? 3,000. Yeah. Don't mistake the soup stock bullion for gold bullion, right? We'll say less than or equal to 100K or something like that. Yep, something like that. Something reusable. Okay. You can buy a car at Costco. So it's Costco. The cars aren't going to be over 100,000, right? Okay. So here are invariants. So the first step. So we got a pod right now, right? Everything's public. So we're going to convert our plain old data to an ADT. This is a process that I when I start coding, I usually do everything as a pod, and then when things start getting complicated, I convert it into an ADT. Which is maybe not the best process, but I like getting my code up and running quickly. And then once I verify everything's working, then I do it the proper way, which again, maybe isn't the most efficient process, but I always like having code that runs. So we'll start off with something like this, like a struct, everything's public, it's a mass collection of variables. And then I make everything private, okay? So there is a third privacy setting called protected, but you don't need to worry about that until we learn inheritance. So for now, just worry about private and public. So, and I don't need that because classes default to private. So I'm going to make a public section now. And the first thing I'm going to do is make a constructor. So a constructor initializes variables so that you don't ever have uninitialized stuff, right? Rather than using a constructor to always initialize things, I like to do something like this, where I'm just setting default values here. And then these things here automatically get put into the constructor kind of secretly. So if I have a food item thing like this, this thing here is called a default constructor. This is a default constructor, and it gets called whenever I make a variable like this. Whenever I make a variable, just a food item, banana, no parameters to it at all, it calls the default constructor. And so we need to give it a name, because the name can't be empty, right? So what should our generic food item be called? We got to give it a name. There's a rule for it. Like, we can't just leave it as an empty string. Name cannot be empty. We have to give it a name. Maximum length of 255, maybe a dash. Food, om-nom, honey bun, milk. In general, maybe it's good to give it like a name that it's clear that it's unnamed. You know what I mean? Like uninitialized food. I don't know, something like that. So that if somebody sees it, like, you know, they know that something went wrong. Consumable, Oreo. What's it called? Jarts. It's called Jarts. Nerps. That's it. Yeah. Jarts is the lawn darts. So Nerps is a new exciting retail product. Have been a background part of Shadowrun since the early first edition. Adverts are generally vague, ambiguous, and contradictory as to their exact nature or purpose. So there have been these advertisements for Nerps for decades, and nobody knows what they are, right? Nerps, it's that simple, you know? For plants, for heat, for lubrication, for demon rat infestations, for that new car smell. What the hell is a Nerp? Nobody knows. Troubled? Nerps, it's that simple. Nerps for endomorphins. 1 out of every 16 billion doctors surveyed recommended it. The 17-to-1 shampoo bottle. Yeah. Nobody ever knows what a Nerp is, so anything could be Nerps. Okay, so now if we try, so we've got a constructor here, and so this constructor secretly gets called here. This secretly calls the default constructor. Okay. And this is one of the reasons why C people hate C++, is because they don't like the idea that functions secretly get called. So, you know, what if the constructor, you know, deletes your file system? You wouldn't know where your file system's being deleted because you can't see it. It's like, all right, you know, fair enough. So good coding style dictates constructors just initialize the variables. That's it. Don't do anything crazy. There's also something called a destructor, which is the name of the class. Again, the constructor it's got the same name as the class, no return type. Okay, and that gets called secretly anytime you make a variable of just type food item without passing any parameters. It calls the default constructor. The destructor here gets called when it goes out of scope. When the variable goes bye-bye. Okay? So when this guy here, like banana here, when this guy goes out of scope, which is here, then it's going to call the destructor. Now, you see that? The destructor got called after everything else is done, right? We had just printed out our sorted vector. When the banana goes out of scope, that's when it secretly calls the destructor. Do you need a destructor? No. In fact, most of the classes I make don't have destructors on them at all. You only need a destructor if you need to clean up after yourself. So has anyone here heard of the internet? The internet. Anyone heard of the internet? 2 people, 1.5. Okay. So the standards people in C++ haven't. There's nothing in the C++ standard about the internet. There's no ability to do internet anything in the C++ standard, which is kind of a big omission to me, but you know, they have reasons for it, I guess. Read about it in a book? Yeah, fair enough. So if you open a socket to connect to somebody on the internet, which is how you kind of do networking programming. We'll probably do that later in the semester. If you open a socket to connect to somebody on the internet and you just quit, that socket is left open for 2 minutes. And if you try running your program again and you try opening up the same socket, You can't. It'll be like, that socket's in use. Go away. And so it's really annoying when you like, quit your program and then you can't run your program again for 2 minutes. You just are like, I guess I'll go get some coffee now and come back when the socket's closed. And so when you have something like that, then you would put like, the socket close, inside of, do you guys understand? Like, so when however that variable goes away, whenever it goes bye-bye, it's going to call the destructor, and then the destructor will shut down the socket. Hey, can you grab the Monster for me out of the fridge? There's a golden one. I don't like the white flavor. It tastes like, I don't know, something. So destructors, they're useful when you need them. A lot of my code doesn't really use them. If you have a new instead of your constructor, then you need a delete inside of your destructor. That's kind of the traditional yin and yang pairing. But I don't use news very much these days. No news is good news. Okay. All right. So step 1, constructor, make everybody private. Step 2, constructor. You can also make a constructor that takes multiple parameters. And so, thank you, Wonderchub. Ultra Golden Pineapple. I've never tried this one before. Anyone had a... This is like going to be my thumbnail for the video, I think. This video brought to you by Monster. And Raid Shadow Legends.
I don't know why, but I always hated how, like, people in YouTube
like
are like, make sure to like and subscribe.
Make sure you slam that like button.
And hit the notifications button.
Yeah, so you don't miss any videos. Oh, gosh. Fast forward. Little finger comes out. Drives me crazy. Okay. So you can also make a constructor that takes parameters. And so we've got 4 parameters in our class. So it's pretty common for us doing like a 4 parameter constructor. There's an extent. Yeah, I have that. It's called sponsor block. But on my television, it's like, fast forward. No, stop talking about Skillshare. I don't care. Okay, so a 4 parameter constructor would allow you to set each of those variables. So instead of just banana, which would always be, NERPs, 0 calories, 0 mass, 0 price, it'll allow us to actually set the variables. So we can have a string new name, a integer new calories, a float new mass, and a flute new price. And we can do something like this. Name equals new name. I'm not doing the vetting for the invariants right now. I'll get to that in a second. I'm just kind of showing you how the constructors work. Calories equals new calories. Mass equals new mass. And there's a better way of doing this as well. And price equals new price. But I kind of want you guys to understand this. So again, this is a constructor. It's a function that has the same name as the class, no return type. So this will secretly get called under the hood if you make a variable of type food item and you pass in parameters to it. So if I make food item pizza and I pass in pizza, calories for pizza is like 180 for a slice. The mass of it is 1.2 something. I don't know what units we're using. And the price is $1.80 a slice. Okay. So we call this pizza slice. So if I was able to see out, which I'm not because it's private, but if I was able to see out pizza.name, what would this print to the screen? It's private, so I can't do it. I don't have getters and setters yet. But if I was able to print out its name, what would it print? Pizza slice, very good, Luke. And its calories are set to 180. Its mass is set to 1.2. And its price is set to $1.80. Okay, see how that works? I'm making an item of type food item. The name of the variable I'm making is called pizza. and I'm passing in 4 parameters to the constructor. The first parameter is the name, pizza slice. Second parameter is the calories, 180. Third parameter is the mass. Fourth parameter is the price. And you can see I'm just setting my name. Pizza's name is set equal to new name. Pizza's calories is set to new calories. Like 180, so on and so forth. Okay. So usually you'll make 1 or more constructors. Pretty normal. I like defaulting anything that's a primitive, like an integer or a float that doesn't initialize themselves. I typically will set them equal to 0 here, so that no matter which constructor gets called, they're always guaranteed to at least be set to 0 if they're not set elsewhere in the constructor. Okay, so the next step for converting from a pod to an ADT is getters and setters. Some languages like C#, you can just write get set and it'll just make them for you. It's really nice. But in C++, you got to write them yourself. And usually you want to write them yourself. If all your functions do is just get and set, there's kind of no point. Like, you might as well just make it public. The reason why we go through the rigmarole of writing these getters and setters, and let me show you what I mean, is so that you can enforce the rules. You can enforce the law. You can enforce the class invariant, right? Because we have a rule, right? Like, you can't have negative calories. And so let me show you void set calories int new calories. So if all we were doing was setting calories equal to new calories, there's very minimal value to this, right? You might as well just make calories public, and you have some issues, like you can't rename calories under the hood, but basically, if all you do is this, like there's no point. But we are going to gatekeep. We're going to do some gatekeeping now, right? Because we have a rule. You remember the rule we set up here? Calories must always be greater than or equal to 0. We cannot allow anybody, either in the constructor or in our setter, to change calories to a negative number. So we need to check for this. So if we try setting new calories, less than 0, then we need to reject it. Okay. So there's a couple different ways you can handle this. You can print an error message. You can throw an exception. You can just ignore it. I think probably the best option is to throw. We'll throw runtime error isn't exactly right. Let's see which ones. Let's see, what kind of exception should we throw? Logic error, invalid argument, maybe. That one sounds good. Rangers. Arguments outside of expected range, maybe. Elements out of a range, more for like a vector. I like invalid argument. We'll do this one. So we're going to include std except here. And so if the user tries setting calories to a negative value, we are going to throw an invalid argument. How many people here have never thrown before? Has never thrown an exception before? Okay. So let me show you what that looks like. Error, you tried setting calories to a negative number. So let me show you what that looks like. Okay. So we got like 5 people that have never thrown before. So let me show you what that looks like. So if you throw, like if the user down here calls pizza dot set calories -10, it's going to throw. Okay. So let's say pizza dot set calories equals to -10. It's going to throw. And so what throwing means is, thank you, autocomplete, never change. What it means is it'll kill your program. If you don't catch the exception that's thrown, it kills your program. So let me show you what that looks like. Terminate called after throwing an instance of stood invalid argument. What? Error. You tried setting calories to a negative number. Death. Okay. So this is good. Okay. It kills your program. It tells you what went wrong. If we really wanted to be cool, we could like put the line number in there and stuff like that. But you know, basically this is enough to go on where I'm like, oh shoot, yeah, calories can't be negative. Oops. You guys understand? But the neat thing about it is that you could catch it. So you can say try. And especially if you're doing something like, you know, reading, you know, CN calories, or, you know what I mean? Like you're reading something from the user. Okay. But you can catch it. So like it doesn't have to kill your program. And so you can see error, you tried setting calories to a negative number. You see that? And the program just continues. So we tried setting calories to negative 10. It throws, so it returns from the function. It doesn't, this line of code here never gets called. When you throw it, immediately bails out of the function. And then if you catch it, then you can print a nice error message, or you could just move on with your life, or whatever you want. And so this gives you better options than just calling die, right? Oh, negative calories, quit the program. You know, like imagine a Microsoft Word, like, you know, you type in a negative font size and it just like quits Word, like, nope, sorry, invalid argument, dead. People wouldn't put up with that, right? So you can catch exceptions, and so if you don't catch them, it kills your program, which is nice. If you do catch them, then you can print the error message set inside of them and see what's going on. Or you could, you know, like the user, like you ask the user to type in calories, and they type in negative 20. It throws an exception. You're like, oh, whoa, whoa. Hey, that wasn't good. Type in another calories, and you could reprompt and things like that. You can handle it however you want. It's a very easy system that still allows you to get a lot of control over errors and things like that. It's really nice. Okay, so our set calories is good. Now we need get calories. We need a getter. So int get calories. And for this, return calories. Getters are almost all very simple. They follow this pattern right here. So when you guys do a little bit of lab time today, you will be, I'm going to give you a half-written class. And what I want you to do is look at the examples that are already in there and then write the missing getters and setters and things like that, following the pattern. And so what this means is every food item now has a function on it called get calories, because we can't access .calories, right? Like we can't see out pizza.calories. That's just not allowed, right? That's going to give us a compiler error. That is a private member, right? Can't touch it. But get calories is public. This is a public function. And so that allows us to get the calories. So do you understand this? So we take calories, which used to be a public member variable, we put it into the private section here. And then we have in the public section a get and set function to read the value and write the value. But the reason why this is so beneficial is because when we try changing the value, we can enforce our invariant. We cannot have a negative calorie food now. We can't have a price that's over 100,000 once we do it. We can't have a name that is the B movie script, right? Once we enforce those invariants. Okay. You guys understand why this is useful? Like, this is a lot more typing than doing a pods, right? So it is more typing. But at the end of the day, you don't want somebody just like changing your defense stat in Pokemon to 0, and then your code starts exploding and crashing because they didn't know that they weren't supposed to set a variable to 0. Because setting a variable to 0 is just what we do, right? We don't know better. We set it to 0. And somebody over in Toronto set your Pokemon's defense to 0, and then now your code's seg faulting and you don't know why. If you have an interface like this, they would have to call set defense to 0, and then you could check it, right? You could gatekeep it. You're like, no, defense cannot be 0. Defense cannot be negative. No. You throw an exception. Now, when they try setting it, their code goes, nope, sorry, you can't set defense to 0. And they're like, oh, I didn't know that. And then they fix it, and it's fine. So there's a real advantage to doing proper class design. Okay, and then inside of our constructor, rather than repeating this code here, we can actually call set calories new calories. So we don't have to duplicate the check, right? And then we can write a getter and setter for name, for calories, for mass, for price. You guys with me on this? You want to see one more, or are you guys ready to try it out yourself? What do you want? I could do this for all 4 of them, but it would start cutting into what time we have left. One more. Okay, which one? How about name? That's probably the hardest one. Okay. So name cannot be empty. No special characters. Max length of 255. Okay, cool. Now the getter is going to be easy, right? String get name. Is it called name? Return name. Okay. Sabrina, it makes sense. So down here, if I wanted to print out the name of the banana, I could just see out banana dot name, or get name, sorry. And you'll see it prints out NERPs, right? Because pizza doesn't have it's just the default constructor, and the default constructor defaults the name to NERPs. So when we print out the name for banana, we get NERPs. Okay. So now we're gonna do the setter for it. So the get functions are easy. The setters are usually you usually are gonna have a gatekeeper in there, some vetting, some if statements. Because if not, then what's the point? So setters are usually void functions because you're not returning anything. It's gonna be called set name. It's going to take in a const string by reference str. Now, is this going to be a const function? A const function does not modify the variable it's being called on. Does a setter modify? Yeah, it can't be const because it's modifying. Okay, so the basic thing we want to do is just say name equals new name. Name equals new name. You guys want to see how Fresno State does this? At least from what I've heard. They like doing this. So they like writing code like this. And so this points to name is the same thing as name usually. But if you have a parameter with the same name as name, then when you say name, it doesn't mean my name, it means this name. And so you have to say this name instead of name to So this is perfectly correct code. I don't like doing it this way because if you forget, then you set x equal to x, and that doesn't do anything. So I like using new name, new calories instead of using this. But just so you guys are aware, you will see people that will write this points to name in real life, non-ironically. What do you think, Megan? Do you like it? So you don't have to come up with a new variable name, right? You just just name this Yeah. So it's name. You don't have to you don't have to make up a new variable name. New variable names are the hardest thing in computer science. So I don't like it because if I ever forget this, then the parameter gets set to itself, right? Like if we say, this points to calories equals calories, right? If I ever forget this, then it sets the parameter calories equal to itself, which is perfectly fine in C++, but it doesn't actually, it never sets the member variable. So I try to avoid it. Okay. All right, so we need to vet this. So what was our rule again? Maximum length. Should we have a minimum length? Is there a minimum length for a name, maybe? 3 letters? 2 letters? What do you think? Can't be empty, but a 1-letter food, 2 letters. Name must be at least length 2 and less than 255. Okay. So, single letter is kind of, I don't know. I might revisit that, but okay. So if new name dot length is less than 2, or new name dot length, you can also use size, their equivalent, is greater than or equal to 255, then we will throw. And I like the invalid argument exception. Throw invalid argument, error. Let's say string, let's see, name must be bigger than 2 and less than 255, something like that. Bigger than 1, technically. Okay, so that'll check for the size. That'll cover the empty string thing as well. Now we want to say no special characters. Okay. Except dash. We'll allow dash. Okay. So we're going to say for every character in new name, if it is not an alphanumeric and C is not equal to dash, is so if they type in like a tilde is not an alphanumeric. Alphanumeric is any letter or number, and it's not equal to dash, then we'll die. Okay. Then if we pass all of our vetting, then we set name equal to new name. And then we can use this up here in the constructor as well, where you say set name equal to new name. And we don't have to duplicate our tests. Okay. You guys cool with that? You like the process? At the end of the day, if we try setting banana's name, let's see here, banana dot set. And Ada, do you know what banana is from? Minions, very good girl. We'll just set its name to a Cavendish banana. Right. So if we do that, ooh, that didn't work. Space is not allowed. Should we allow a space? Actually, that's an interesting question. What do you think? Should we allow spaces or disallow spaces? What about underscore? Maybe underscore too. There we go. So now we can successfully set the name of the banana to Cavendish banana. Yep. And then you guys see how this works? So usually instead of saying banana.name, we call banana.setName and banana.getName. This is proper class design. Okay. Space, yeah, okay. So yeah, so sometimes like password, like it drives me crazy sometimes. Like these stupid websites that are like you have to come up with like a 10-digit password that is like letters and numbers, but you can only use 3 different special characters, and you know, like try using $sign. They're like, no, $sign's not allowed. I'm like, why? Yeah, why would you not allow me to use, you know, asterisk or something like that, right? Like, what's the point, you know, of making my passwords weaker? It just kills me. Okay. All right. So what we've got for you guys, and this is both on the old server and the new server, is we got up in temp main.cc. We've got a enemy class that we were working on in the previous section, in the 12 o'clock section. And so they came up with some invariants. This is like for a role-playing game or something like that. And they have some maximum hit points, current hit points, a name. And so the rule for maximum hit points must be greater than, should be greater than 0, I think. I think greater than 0. Like, it doesn't make sense for max HP to be 0. Current HP must be greater than or equal to 0 and less than or equal to max HP, right? Can't have a current HP of 20 out of 10, right? The name... The name only contains alphanumeric characters, no MP string. Names must be greater than or equal to 3 characters and less than or equal to 15 characters. Location can't be null. Okay. So, you are going to have to write the 3-parameter constructor here, which takes in max HP, current HP, and new name. The destructor, you can get rid of that. It's not really used. You're going to have to write this. I'm just going to tag these with you. What else?
To making us do more homework because of the Latin roots are one letter different from the other Latin roots. They're making us do more homework even though it's literally the same thing. Quirm and quiz or quirm.
What if your current HP was temporarily increased? Yeah, we talked about that. Like in Team Fortress 2, right? The medics can like overcharge your health and things like that. And they decided no. Basically, they're like, you can't. You know, your max HP must be at least 1. Your current HP. And we also talked about, can you have negative health, right? Because like in D&D 3rd Ed, if somebody hits you, you can go down to like -8 health. And you have to be healed up out of it to come back on your feet. And they're like, nope, 0 is the bottom. You can't set health below 0. So yeah, currently it's throwing an exception, but I would almost say if they tried setting the max HP to like, if they tried setting current HP to like -10 to just clamp it to 0. You know what I mean? That's how I do that. Negative health, yeah, it's kind of like how dead you are. You know, like if you're at -100 health, you need a lot of healing to get back up on your feet. You're just here for kicks. Nah, it's great having you here. Do you want to do it? Do you want an account on the server? Missing 4 limbs. Yeah, right. Yeah. Okay. So anyway, so what I want you guys to do, and so let's just do it on the old server for now. So what I want you guys to do is copy this file into your current directory and call it cobalt.cc or enemy.cc, something like that. And I want you to fill in the missing blanks. Okay. So this is not official lab time. You're not going to get graded on it. But I want you to work on it. I don't want to see anyone like disconnecting, like, we're not being graded. Bye. I want you to actually work on this and see if you can get down the process of writing a constructor, writing a getter, writing a setter, that kind of stuff. Okay. So I'm going to go ahead and pause the recording now and go ahead and stream yourselves working on this. And and if you get stuck, let me know. If you have questions, let me know. I'm going to be watching you all coding. So go ahead and start streaming. This is what I want you guys to type. And I'll even put this on Discord for you to copy. Like that. The temp folder is shared among all people. It's a world readable and writable directory. And so the TA created this for you guys in the previous section. We just tossed it up into temp. Like if you ls-l temp I guess I choned it, but so you're going to copy temp main.cc to me.cc and then work on that. All right, welcome back, and let me show you how I would do it. .cc, current directory enemy.cc. If you guys are still not comfortable with Unix, make sure that you go to the tutorial center in person online. There's only 5 commands you need to know, but do the tutorial online. You really need to know Unix, and it really will make a huge difference in your life. Okay, so what do we got here? We got this enemy class. We got some class invariants for it. Okay, so what I recommend doing first is just getting something that works first. You don't have to do everything all at once, right? So before we worry about the invariants, let's just get something that works. So let's just say max HP equals new max HP. Let's say current HP is equal to new cur HP. And let's say name is equal to new name. You'd see my TA likes camel case. But that screws with the capitalization. Okay, so this isn't vetting. This is not enforcing the rules, but it's a start. Okay, so trying to write this in half Python. Okay, so that is a start. We don't need the destroy call. We don't need a destructor at all, really. I don't need you at all. Just default it. Okay, getters, setters. Okay, and get max HP, current HP. I know, right? It's curlock. I didn't write these. Okay. Get name should just return name. Did you guys all get that? What I set up here was like some demo code with some parts of it done, and all you have to really do to succeed in computer science as a whole is like pattern match, pattern recognition. See how, okay, that's how we get the max HP. That's how we get the current HP. Well, then that's how you get the name. Okay. So, and then this one required a little bit more. For this one, we needed to put the const in there as well, and then return starting loc like that. Okay. And there we go. Okay, so the getters are done. The 3-parameter constructor is half done. We're not vetting yet, but we'll get to it. And then you have to do all of these. And so this is going to be kind of time consuming because you have to make sure all these values are correct, right? Let me actually copy the invariants, Shift V, Y, And I'll just paste these down here. Okay, so current HP gets set to new current HP. So cur HP equals new cur HP. So that's what we're going to do without vetting, but we want to vet it. So the rule for current HP is that it has to be greater than or equal to 0 and less than or equal to maximum HP. And as I was saying, like if somebody tried setting the current HP to like -10, I would probably not die. Like I would probably not throw an exception for it. I would just clamp it to 0. You know what I mean? So, because like in the game, like there's going to be some line of code like you get hit for 10. And so you say like your HP is set to your current HP -10. And if you throw an exception, oh no, you've set the XP to -3, it's going to kill your program when you kill a monster, which is ironic. I probably would actually do this instead. So I'd say if new current HP is less than 0, I wouldn't die. I would actually just set current HP equal to 0. Does that make sense? So if you kill somebody to -30, they're at 0. You kill them to -100, they're at 0. And again, this is a decision. It's something you have to decide for your game. Like, are you going to allow negative hit points or not? You know, like Megan said, you know, allowing temporary hit points above the maximum is something a lot of games allow. And negative hit points makes sense. Like if you have a death store rule where people are bleeding out, like they're unconscious, they're at -7. The next turn they drop to -8. The next turn they drop to -9. And when they hit -10, then they die for real. So it just depends on the rules of your game, which things you allow. These rules were set by the 12 o'clock class. Okay, so if current HP is less than 0, you set to 0. Okay, but now this one, yeah, they're not allowing any excess. And so again, maybe I wouldn't even kill it. Like if you heal somebody, you're like, okay, your current hit points plus 20. You know, I would just clamp it, honestly. Like I'd probably just set it to the max. You know what I mean? Like if their max HP is 30 and you try healing them up to 35, I wouldn't die. I'd probably just keep it at 30. So I could do this again. Actually, there's a standard library function called clamp. And clamp is actually C++ 20, I think, added clamp. 17. Okay. So it takes in a low value, a high value, and then it returns if it's in the range. Okay, so if you it doesn't have any good examples. Okay, here we go. So if you clamp it between 0 and 255, if n is less than 0, it returns 0. If n is greater than 255, it returns 255. Otherwise, it returns n. Okay. So, yeah, let's use clamp. Okay, so we will set current HP equal to clamp new cur HP between 0 and max HP. And clamp is found in which... You don't have to do it this way in if statement algorithm. I thought I included algorithm. I have to give them the clamp. Okay. Oh, I erased it. Okay. Clamps. Why do you always give them the clamps? All right. So that would actually work, I think, pretty well. One line. Or you can do it with if statements or whatever. And if you guys threw, it's fine too. Like the example I gave you involved throwing an exception. So if you throw an exception, it's A-okay. All right. So for the name, we need to... do you guys understand this? What this is doing here? So if new current hit point is like -10, it'll return 0. If it's like 1,000 and max HP is 30, it'll return 30. Otherwise, it'll return the value if this is between 0 and max HP. Okay. Set names, we need to check to make sure it has only alphanumeric and no empty string. Okay. And probably we want to add max. Okay, yeah. We have a string right here, 3 to 15. Okay. So the empty string is actually redundant because it's got to be a minimum of 3. Okay. So if new name dot size is less than 3, or new name dot length is greater than 15. Length and size are the exact same thing. Then we will throw a invalid argument exception saying names must be between 3 and 15 characters. That's good. So if they try setting it to the B-movie script, it'll throw an exception and kick it back. Okay. Would your highlighted line also work to set current HP to max HP? March. Let's see here. Double click. If new current HP is greater than max HP, current HP equals max HP. Yes, that's actually what I was going to write before I did clamp. So what I had before was if new cur HP is less than 0, cur HP equals 0, and then I was going to say if new cur HP is greater than max HP, cur HP equals max HP. And these two lines of code are exactly the same as these 3 lines of code are the same as this 1 line of code. So take your pick. Okay. All right. Where was I? Okay. So, and then we also have to kill the program if they try setting a non-alphanumeric. Okay. So we're going to do what I had before. For every character in new name, if that character is not an alphanumeric, is alnum, then we will throw an exception saying names must only be alphanumerics. And then if all that passes our test, then we will say name is equal to new name. For the starting location, the ending location, these guys take pointers, and so the rule is it cannot be null. So if not new starting location, so in other words, if they pass in null as a starting location, then we will throw location pointers cannot be null. It's 2 R's for this one, and it's 1 R for the other one. New curve. 4 locos, and there we go. So we're going to create Bob. That's going to call the default constructor. We're going to create a kobold. It's going to have a max HP of 15, a current HP of 15. Its name is kobold. We can get Bob's current HP. We can get kobold's max HP. And then if we try setting Bob's max HP to a negative number, then it will clamp down to, I'm on the wrong file. It will clamp down to 0. New max HP cannot be negative. Actually, yeah, max HP doesn't clamp. Current HP clamps. So this will throw. Okay. You guys understand? So if you try setting the value to an invalid, if you try setting the value to an invalid value, then it dies. Okay. Could you also check for the pointers being null using double equals null pointer? You can. Yeah. This is a shortcut. It's exactly the same as that. Same thing. Just less typing. Guys, do you see the benefit to this? So now we can guarantee, because the only way the code has to set the maximum hit points is by going through the constructor. and by going through the setter. And speaking of the constructor, let's read that. IntelliSense always does that. Super annoying. Okay. And this will reuse the vetting down below. So we don't have to repeat that code. Some people do. Some people put their vetting in both places. I don't know. I don't like I don't like repeating myself. Did you guys hear that? I don't like repeating myself. Did you get it? I don't like repeating myself. Ada?
What?
Does Daddy like repeating himself?
You often do it.
I often do it? No, I don't. I don't like repeating myself. Huh? Huh? Is that a dad joke, Ada? Yeah. She had a very sad tone in her voice. I don't know if you guys heard that. She's like, yeah.
There's nothing to be proud of.
There's nothing to be proud of, dad jokes. Okay. So that's class for today. You have any questions about this? This is proper design. It prevents our enemy from ever falling into a bad state. It keeps us safe. We can rely upon these invariants in the future. So every time we get the name of an enemy, we don't have to constantly check, is its size too small? Does it have non-alphanumeric characters? Is it too big? Which we would have to do otherwise. And then if those invariants change, if we ever set a different size policy, then all those places outside of us where we were checking to make sure they're valid would have to change also. And so this is called encapsulation. You can put everything related to an enemy in one place, and they're separated from the outside world. The outside world has to go through an interface to get to it. And so that gives us freedom. If I want to rename max HP to be Ma HP, the only place where I have to change that is inside of my own code here. As long as the interface stays the same, as long as the interface to the outside world, the liminality, the edge, the border, as long as that border stays the same, I can refactor my code however I want. I can rewrite it to be more efficient, to be more space efficient. And the outside world doesn't need to know any of my rules. They don't need to know, that, names can't have alphanumeric characters in them. Because if they try anything different, it throws and tells them, like, hey, you're going to break my code if you do that. So, this is a new way of programming. It's we're getting into what's called object-oriented programming, where the brains, the intelligence of your program is inside of a class instead of inside of main, which is where it was in CSI 40. In CSI 40, we did what's called procedural programming. Now we're doing object-oriented programming. So make sure you guys get your homework done by Friday, deal or no deal. Get deal or no deal done by Friday. And then on Friday, we're going to move to the new server. So we're going to be moving to UNIVAC. Make sure you follow the directions on there. Get set up for that because your next homework is going to be on there. And with that, I bid you all adieu. Bless you. Thank you. Appreciate it. Bless you all too. Have a great night. If you did do it on the old server. I don't know. I'll figure it out. Do it on the old server. Okay. Adios. See you guys.